Alright, so we are back again, and man, I just get this thing wrong every single time. First off, that didn't make any sense. But, I keep forgetting, you have to hold both the inputs high in order for it to be in a stable state with the NAND gate RS flip-flop. It's like, why can I not get that in my head? It's like, oh, why am I doing this silly video? This is not what I wanted to go on. I just felt like I really needed to get this thing to work. So anyway, actually this is the way around that you want the diodes to go. What I just said before didn't make any sense. But instead of going to pulling it up, pulling it down to ground, you want to pull it to your positive voltage. So V plus, or plus V. And that should work. So this way, there is no connection between here and here because the diode is facing that way, and that same for that one there, but you can pull them up to high voltage. So this is high, then that will be high and high and high, and in fact it does work. So now I've changed it around so that these things, it's really weird how now my brain is starting to work. So when I press the button, it will in fact stop on one of the LEDs, and when I let go it starts flashing again, and when I press the button you can stop on a different one, and ooh, something just fell off the shelf, and so it does in fact now appear to work. So that wasn't too hard. So remember, when it's doing this, the oscillator is still going, it's still alternating between things, it's just that I'm pulling it up to high, and so it's fine. So it's just ignoring everything else because these things are being pulled to whatever value they are by these resistors, via these resistors. So they're weakly pulled to whatever the oscillator is outputting, and then they're strongly pulled to high when I press the button, and so that's overriding the stuff. So that means it kind of works, which is cool. Now what we have to do is, I don't want this bit here, I don't want to use one of these, I want to use one of these circuits. Not one of these circuits, I want to use the 4011 to do it. So I'm going to go back to this book. So I'm not going to try and explain how this actually works, because I haven't quite sussed it out yet as to why it oscillates. So I was going to do a separate video about it at some point. I'll turn it off for a second. And you can't really see it, but this is the kind of circuit here that you want to build, and it looks kind of like this. So there's this two NAND gates put together, and you've got an enable thing. You can do this exact circuit with a 4049 essentially, which I have done. That's the only time I've ever done it, and then it will oscillate at a nice frequency. So what does this one say? It doesn't tell you. It says 1000 Hertz for this. So all that's changing is there's a capacitor here, and then there's two resistors. Which hopefully I have the right ones for. So I keep reading stuff about this relies on the protection circuits or something, diodes inside CMOS chips, and I don't understand how. But I'm going to try and work out how this actually works one day and talk about it on this channel. But today we are just going to make it. Now there's only one little problem here, is that this uses two NAND gates, and in my little circuit, and there's the output from here. So you can't see that, there's the output there. So NAND gate, this complicated arrangement. It's not that complicated, but when I tried to make it before with the 4049, it was very confusing. And you get one output, but I'm hoping that we won't need, so that would require 5 NAND gates. If I take the output from my oscillator, put one through the inverter, and then the other one over here, straight into these things here. So also remember, these are all CMOS inputs, so there's no loading. So on this one here, you kind of probably have to worry a bit about how you load these things, but it's fine. But you don't actually need the inverter, I don't think. Well, I'm hoping, so this is what I'm going to try, is that you could just tap into here. So instead of getting the output from this bit here, just from here. So this is one output, but the complement should be here as well, because whatever is here is going to be inverted and coming out here. So you should be able to get the inverse here from the output and tap it into there. So we don't need to have the inverter step. So then we're using up 2 NAND gates plus the 2 NAND gates for this, and we should be all good. So let us build this. So we're going to have to dismantle this. So we're going to take these bits out. We're going to need to keep this wire in for now. even though it looks a little bit on the heavier side. But we could probably put it over on that side. Oh, I shouldn't have taken it out because now I can't test it. Okay, it was just going to stay there, isn't it? So we took away our oscillator. So we can now have a look at this bit here. So I'm probably going to have to keep these exactly where they are. First thing is, I've just got to see if I can dig up. So what do I need? I need, these things seem pretty consistent, a 100k and a 1 million. Well, I don't actually have a 1 million on me at the moment, so I probably do. So I keep these things in here. I always think this is an interesting way of doing it. It seems to work. Well, there's a 100k. So we'll just use a 910k for the instead of the million one, and we'll use an actual 100k for here. So I'll make sure I know that one's got the orange on it. What did I just drop on the ground? Something important. And just double check I don't have any 1 million. Why don't I have a 1 million ohm in this little book? I have another one. It's all upside down. You can't see what I'm doing. Well, it's probably very annoying to do that on this channel. So I feel like this is like me learning stuff and making, but I feel like I know more than what than what I've done so far. I've just been making lots of silly mistakes because. But this is what you get when you do these kind of things. You get better at it over time. So that's a good thing. So I'm going to take this. So here is a picture of the circuit I'm going to make. This one here. They're very similar, these things here. They just vary. This one's for making a tone for a speaker, and that one's for making an LED flash once per second. So I'm just going to take that and turn it around, and then I'm going to build it and just explain what I'm doing. But I feel like I should have had the picture somewhere. So this can be the first one. So the first thing is the enable pin. I'm just going to tie to high because it's always going to be enable. I don't think it's going to keep its state. So so the nice thing about this is that you can send a voltage through there. So if that's high or low, then it will oscillate. Probably should check that. And when it's the opposite way around, it won't oscillate. So you can kind of turn it on and off pretty easy, which is a nice little feature, right? But we'll just take this input and we'll just make it high so that it can be always that way. So that makes sense. If it's low, then the output will never change because it's a NAND gate. So I think we went through that before. I've kind of lost our... No, I haven't. What did I do with it? I have, haven't I? And I forgot which was which. So this is the 100k. So what did I do with the other one? It's gone. It's one of those days. My poor supply of 910s. Okay. But I got all of these out one of those little packs you get off. Okay, sit there and don't get lost. You can buy off AliExpress. I do have 1 meg one somewhere. In fact, I bought a whole pile recently. Probably so I can make the circuit over and over again. Alright, and so the 1 meg is got to connect from, alright, so we're going to have, so I need, I've gone and lost, to take these things out. Alright, one, I'm going to keep that one in for now. And I'm dropping things all the way on the floor. Alright. So, first thing is the output of the first one goes to the input of the next one. So I'm going to take that one out, which are tied together. So, which ones are tied together? Well, these two are already tied together, so that's handy. So I'm going to take the output, which is this one, and then I'm going to transfer it. That's a bit messy, that one. Goes in a diagonal. So between this one and that one, so from the output of this one, we've got the 100K. This is where I get confused. And the 100K has to go to, I'll just put it over here for now. So that's going to look a bit strange. And we need this one, and that's going to come from one of the inputs to there. Well, this is going to get really complicated. We're going to have some wires crossing here, that's for sure, but that should be okay. So that one's going to go to there, and this one's got to be see what I mean? This is just it's a strange little circuit. So that one's got to be tied to high. Alright, so one input, and now we just need our tiny 0.1 microfarad, and I just happen to have a whole pile of 0.1 microfarads here. So I think 1000 hertz should be enough to be convincing. I don't know how old these are or what they are, or how good they are, but they've got nice strong little wires. So that's something. These are old school, old school stuff. All right, and then so from this little point here, we have to connect this, and this is a nice one. This one's not. This is not. This is bipolar. It's not polarized. So the output of the other one has to go to, you can't see what I'm doing, and I can't see what I'm doing. Oh, okay, hold on. That one can go there. Everything's touching each other's wires. So this is turning out to be a bit of a mess. And that's the output of that one. Alright, well, we've done something strange here because this is no longer connected to anything. So this one can be connected to the output of one of them. It's nice that they're symmetrical on the IC because that makes it easier to understand what I'm doing. And that one can go there. So I think this is going to work. I think we've done it. I probably feel like I should explain what I've tried to do. So I'm going to bring the circuit up kind of close so you can see. These all meet at one point here. So this line here is one little junction, and then they go off to 3 different places, which is the way that it's laid out here. So all of these 3 components meet at this junction here, and then they go to the 3 different parts where you can intersect with the NAND gate. So one of them is going to the end of this one of them is going to the end of this one, and one of them is going to the input. So hopefully I've got them the right way around. And let's see what happens. So when I turn it on, these should flash really fast. Maybe they are flashing really fast, and I don't know, because it actually, you can't see this, but I think that is actually flashing at 1,000 times per second. So now it works, just like that. It works. So finally, after quite a lot of worry about this, we appear to have a random number generator. So let's just quickly, alright, so I'm going to write at the top of this one, H. Well, should I write heads or tails, or should I write, no, we should just write, so heads and tails. So green is tails. We can really get the cables out of the way. Not very considerate to people watching the video. And there's this giant wire here which is getting in the way. We just can't seem to, I can't seem to avoid getting, okay, that one can just go through the middle there. And into there. And then it will look a bit nicer. This is why it's nice to have PCBs. Alright, so there we go. So I am going to do this 20 times and we're going to see how random it is. Oops, I'm going to turn it on. That's the wrong button to push. So we've got 1 for heads, 2 for heads, 1 for tails, 1 for heads, 1 for tails, 1 for tails, 1 for tails. Ooh, tails is coming out in a head now. Okay, 1 for head, another 1 for head, so we're at 5. And oh, another 1 for heads. Oh, Tails is catching up, good. And Tails is there. So we're half and half now. So there's another one. There's another one. Oh, Tails is coming out in front now. Oh my goodness, this is bad. Shooting ahead. Oh dear. We've got another heads. We've got another heads. It doesn't seem like very random, does it? Well, that was weird. They just managed to catch up. So at 2020, we've got half and half, but that seems very suspicious. Well, that's nice. You want it to flip around, but it's one of those things is that people tend to misinterpret how random numbers look, and so you tend to get a lot of things in a row with this kind of circuit, with coin tosses. But I don't know if that's like, it feels like it has to be. Well, we did that one. We got a red. But seriously, it seems to be like, okay, we've got a green. That's what you kind of want to see. You don't want to see like three tails in a row. You want to see like one heads, one tails, two heads, one head, one tail. You know what I mean? So it seems suspicious that you get like. So there you go. See why I got 4 tail, but then there's only a 1 in 8. There's a 1 in 8 chance of getting 3 in a row. And there's a 1 in 16 chance of getting a 4 in the row. And we keep getting 4 in a row quite often. So how many times do we get 4 in a row? Well, I don't know. That feels random enough to me. Well, we haven't got a 5 in a row. So there's a 1 in 32 chance of getting a 5 in a row. So if I did 5 button presses, then you would expect. Oh, it's actually kind of hard to work out off the top of my head what the probability of getting 5 in a row would be. Because you could say, well, if I did 5 button presses, then there's a 1 in 32 chance of getting all 5 being heads, and there's a 1 in 32 chance of getting all tails beginning all tails, right? So there's a 2 in 32 chance of getting 5 in a row if you do 5 button presses. But of course you're not doing 5 separate ones. You're doing, 5, and then you're doing another one. But then you've still got, so that set could be. But then you could do another one, and then that set could be 5 in a row. So I don't know, I used to be good at stats, but I can't think off the top of my head how to calculate what the actual probability it was, given that you're doing a continuous stream of clicks and you're always tracking the last 5. But anyway, that's just me going off on a tangent because I'm just happy this works. So I'm going to leave it there, and we're not going to talk about this ever again, and we're going to go back to doing, we are going to make an oscillator circuit that I do understand, and we'll talk about that. So one more time, I'll make up a better picture of how the circuit looks if anybody actually cares. That's what the circuit from the book is for the oscillator. And I have tapped in to there. That's going to the set or something of the latch, and that's going to the opposite one, the reset of the latch. So those two are connected to the latch from at that point there. So I hope that makes a bit of sense if you wanted to try and make this yourself. Because I did Google coin toss circuits with a 40111. Well, 4011, and I didn't see anybody doing it. So hopefully this is a novel circuit, and we did use only one 4011. So thanks for watching. Bye, like, share, and subscribe.